Question 8a. So integrate, first of all, e to the power of minus 3x add 5. So that is your e, staying exactly the same power, but dividing by the differential of the power, which is a minus 3. Okay, and that rule only works when the power is linear. Okay, so it wouldn't work if you had an x squared in there at all. You can pull the 3 to the front if you want as a minus 1/3. You can certainly pull the minus to the front. But as long as you've used the rule correctly, you should get your mark there. Part 2. Integrate x squared ln x. Now this one's a product, so we need to use our by parts rule. Okay. Which you can look up from the formula book. It's the integral of uv dash is the same as uv minus the integral of vu dash. So when you're choosing which is which, the ln is always the u, because then you can differentiate it. So we differentiate that one. V dash therefore is x squared, and we need to integrate that to get to v, so that would be x cubed over 3. Okay, so all of that is coming into our answer. So we've got the integral of x squared ln x is equal to our u times our v. I'm not going to multiply any of that algebra together. This is inside the log, and this is just timesing outside. So on the next line, I'll put that term in the front. Minus the integral of our v times our u dash. Okay, so this we need to tidy up. We don't keep it as two separate timesing terms. We can actually do a bit of cancelling and get rid of one of the x's. So it's now no longer a product anyway. We can just write it as the integral of x squared over 3. And that's something we can now integrate. So we cancelled out an x, but now we're going to go back up a power as we integrate. So we go back up to x cubed. We divide by another power of 3, another value of 3. There was already a 3 on the bottom. Another 3 joining it makes over 9. And then we remember the plus c.